Welcome to Beyond the Brackets. Today we'll look into linear differential equations. An equation of the form dy by dx plus py is equal to q, where p and q are either functions of x or constants, is called a linear differential equation of first order. Its integrating factor is given by e power integration of p with respect to x. The solution is given by y multiplied by the integrating factor is equal to the integral of integrating factor multiplied by q with respect to x plus c. In the first problem, we are asked to solve the given equation. Before we begin with the solution, let's first identify whether it is a linear differential equation. A linear differential equation is always of the first order, meaning it will contain the term dy by dx along with a y term, while the remaining terms depends on x. To bring the equation to the standard linear form, we don't want any coefficient with dy by dx, so we divide the whole equation by x. Now the equation is of the form dy by dx plus py is equal to q, where p is the coefficient of y, that is 1 by x, and q is the right hand side, which is log x by x. So the integrating factor is given by e power integration of p dx, where p is 1 by x, whose integration will be log x, which simplifies to x. So the integrating factor is x. Solution is given by y into integrating factor is equal to integration of integrating factor into q with respect to x plus c. Substitute x as integrating factor and log x by x as the value of q. We get integration of log x with respect to x plus c. The integration of log x can be written as integration of 1 into log x. According to the Eilert rule, log x is taken as the first function and 1 as the second function. So we write the first function as it is, that is log x, and integrate the second function, which gives x. Then we subtract the integral of the product of derivative of the first function and the integral of the second function, which gives integral dx, and that will be x. So integration of log x will be x log x minus x. This concludes the first problem. Now moving on to the second problem. Once again, to reduce the given equation into the standard form, we don't want any coefficient with dy by dx, so we divide the entire equation by x plus 1, which reduces the given equation in the form dy by dx plus py is equal to q, where p is the coefficient of y, that is minus 1 by x plus 1, and q is the right hand side, that is e power 3x into x plus 1. Its integrating factor is given by e power integration of p with respect to x, where p is minus 1 by x plus 1. Integration of 1 by x plus 1 will be log of x plus 1. Since b log a is same as log a power p, so e power minus log of x plus 1 becomes e power log of x plus 1 to the power of minus 1. Also, since e power log x is same as x, so this becomes x plus 1 power minus 1, that is 1 by x plus 1. Solution is given by y multiplied by integrating factor is equal to integration of integrating factor into q with respect to x plus c. Substituting the values of p, q and the integrating factor, we see that x plus 1 in the numerator and in the denominator cancel out, and we are left with integration of e power 3x, which gives e power 3x divided by 3. So that's the solution of this problem. Now moving on to the second problem. This given differential equation is already in the standard form dy by dx plus py is equal to q, where p is the coefficient of y, that is secant x, and q is the right hand side, that is tan x. Integrating factor is given by e power integration of p with respect to x, and the value of p is secant x. Integration of secant x is log of secant x plus tan x. This further simplifies to secant x plus tan x. Solution is y multiplied by integrating factor is equal to integration of integrating factor multiplied by q with respect to x plus c. Substitute the values of q and the integrating factor. Separating the integrals for both the terms, we get integration of secant x into tan x with respect to x plus integration of tan square x with respect to x plus c. Here tan square x can be written as secant square x minus 1. Integrating further, integration of secant x into tan x with respect to x is secant x. Integration of secant square x is tan x, and integration of 1 with respect to x is x. Moving on to the next question. Again, the given differential equation is in the standard form dy by dx plus py is equal to q, where p is the coefficient of y, that is 2, and q is the right hand side, that is e power x plus x. Integrating factor is given by e power integration of p with respect to x, that is 2 with respect to x, so it becomes e power 2x. Solution is y into integrating factor is equal to integration of integrating factor multiplied by q with respect to x plus c. Substitute the values of q and the integrating factor. Integration of e power 3x plus x e power 2x with respect to x. Integration of e power 3x will be e power 3x by 3. For the second term, x and e power 2x both have x, So we use integration by parts. Again, applying Eilert rule, x will be the first function and e power 2x will be the second function. The first function x will be written as it is. Integration of e power 2x will be e power 2x by 2 minus integration of first function, that is x will be 1, and integration of second function, that is e power 2x by 2 will be e power 2x by 4. That completes the general solution. In this question, boundary conditions are given like y of 0 is equal to 1, which means y is equal to 1 when x is equal to 0. Substituting these values in the general solution, we get c is equal to 11 by 12. And by putting this value of c back into the general solution, we get the final or complete solution. I have added some extra examples along with their final answers.